This tutorial discusses the development of the periodic table and how it's designed. Dmitri Mendeleev developed the modern periodic table. He argued that elements' properties are periodic functions of their atomic weight. What that means is that when elements are arranged by increasing atomic mass, certain sets of properties recur periodically, and this is known as the periodic law. Elements having similar physical and chemical properties fall within these columns. We now know that element properties are periodic functions of their atomic numbers, not their atomic mass, but he was unaware of atomic numbers at the time. So let's take a look at Mendeleev's periodic table and our modern one. This is his original. You can find some patterns. For instance, if you look at these right here, beryllium, boron, carbon, nitrogen, and oxygen, boron, carbon, nitrogen, oxygen, fluorine, they're all in a row in Mendeleev's, and they're all in a row in the modern one. We can also look at how some other things are paired up. For instance, the halogens. Fluorine, chlorine, bromine, iodine, they're right here. So actually, if you take Mendeleev's original periodic table and turned it 90 degrees, you would have very close to our modern periodic table, which is why he's credited with the development of the modern periodic table. He used a pattern to predict properties of undiscovered elements such as gallium and germanium, which we'll talk about in just a second. He also, because he was focusing so much on the properties and not the masses, he noticed that that doesn't always follow the trend. So if we look from left to right on the periodic table and we follow the masses 118.71, 121.76, this one's TE is 127.60, but iodine is 126.90. It goes up and back down. And that's because of their periodic properties, because of the chemical properties of those elements, not by the weight. So he actually reorganized it to make sure that the properties, the physical and chemical properties, are the ones that are being observed, and not just the weight. Mendeleev's periodic table allowed for the prediction of elements not yet discovered based on their physical and chemical properties. So here's gallium, and here's germanium. This is what Mendeleev had predicted. That would have approximately 68 AMUs for a mass, and it's actually 69.72. It's a little bit high, but it was very close. It has a very low melting point, which its actual property is 29.8 degrees Celsius, which is still fairly low. Density he thought would be 5.9, and that was right on. And here's some reactivity formulas. The ratios were exactly what Mendeleev thought it would be. Germanium has similar results. He thought it would be approximately 72 AMU, and it was actually 72.64. The density was actually a little bit smaller than what he predicted, but still very close. And the reactivity, it creates the same ratio as he had predicted. The elements on the periodic table are arranged from left to right in increasing atomic number, which is the number of protons. So the atomic number, once again, are the whole numbers, smaller whole numbers on it, and those are telling you how many protons there are in that element. The rows in the periodic table are referred to periods, and that's going from left to right, and that's telling you what energy level it is and how far away the electrons are from the center of the nucleus. And then the columns up and down are sometimes referred to as families, because the elements within the column have similar physical and chemical properties. And that's what he was referring to, that the reactivity reoccurs periodically. So the reactivity of these elements reoccur as you go from left to right. and come back again. The elements, their names, and symbols are given on the periodic table. So that gives you a general idea of how the periodic table has been organized.